Good afternoon, everyone. Just going to take things slowly while more of you pop into the call. Welcome to you all to another spring showcase. Very excited that this is our 31st showcase now. So welcome to you all for that. Really excited that today we've got a team from Jacobs, from First Utility District of Knox County and Hitachi. And all of those presenters from each of those businesses are going to tell us about the lessons that they've learned from a project to streamline sewer inspection and planning processes using AI. For anyone who doesn't know who Spring is, we are the Innovation Centre of Excellence for the UK and Ireland water sector. What we noticed in the UK, probably around 4 years ago now, was that there was really great innovation happening regionally, but there was a lot of duplication happening because it wasn't connected and there wasn't as much collaboration as possible happening. So Spring was born out of that idea of removing duplication, and we're here to create centralized intelligence around what already exists. So practically what that means is, for the benefit of both water companies and suppliers, we will share knowledge. That could be at a really high level in terms of what projects already exist. It could be at the deeper dive level, like today, in terms of lessons that have been learnt from a project. We also put calls for innovation out as well to help solve problems in the sector. But today is all about one of those deep dive sessions. I just wanted to touch a bit on why we do knowledge share before we jump into the session today. So we all know our sectors, in no matter what region of the world we're in, are all under significant scrutiny at the moment, and we really need to accelerate problem solving. So knowledge sharing is one of the ways that we can do that. And over the last 6 months, we've actually partnered with the economic regulator in England and Wales to build out a view of what does best practice knowledge sharing look like. So I just wanted to quickly walk you through that so that we all have an idea of what we're trying to do in terms of knowledge sharing. So we brought together senior leaders, innovation managers, water companies, and we will be having a future session with suppliers to design a vision for knowledge sharing. So what is it that we're trying to achieve? Ultimately, we want to unlock faster adoption by creating a world-class knowledge sharing culture. So then we built out 6 best practice principles. So what does the standard, the best practice standard look like? So we want to make sure we learn from what already exists before committing to innovation projects. So Spring is building a centralized source of data on what already exists. So before new investment is made, you can come and check in with us about what already exists so that you can learn from it. We want to target innovation insights to the right audience to meet our objectives. So we want to make sure the right people are there listening to the lessons. So for today, are the sewer inspection people on the call? Are the right budget holders, decision makers involved in the lessons learned? Number 3, insights are regularly shared through multiple channels from day one of the project. Historically, knowledge share has happened at the end of a project. We want to start moving towards a model where we share from day one. So what is it that we're trying to achieve? When will the touch points be when knowledge is shared throughout the project? Number 4, sector knowledge is open and centralised. So we want to make sure that we're all being open with knowledge and that it's centralised in one place, i.e. Spring, because fragmented knowledge makes it very difficult for the user to engage with. Number 5, insights from both innovation successes and failures are shared. So as we all know, the lessons learned from failures are just as important as lessons learned from successes. And hopefully we'll hear from the team today about challenges that they overcame along the way of this project as well. Number 6, people are empowered to receive and embed lessons from external sources. So we, Spring, and presenters on this call can all share knowledge. However, we need to make sure that the resources that are going to make the change are empowered to make that change, that they have capacity to make that change. So those are our 6 principles. In terms of what it is we are sharing, for anybody who doesn't know, the UK and Ireland has a water innovation strategy, and the team will pop a link into the chat of that. It has 7 themes that would be relevant across the globe for water utilities. So anything from providing the services our customers and society expect, resilient infrastructure, through to enabling diverse, future-ready people and partnership working. We will also be holding a session on the 21st of November, which is an open session where we'll be doing an interactive workshop specifically around how we're going to embed these principles in the sector. So we can also drop a link to that in the chat. And if you'd love to come along, please register for that. So with that in mind, let's focus in on today's session and have a look at the agenda. Really happy to say that we've had nearly 100 registrations for this call. We've got 10 UK and Ireland water companies joining us. We've got lots of overseas colleagues as well, many US people, which is completely understandable. We've also got Australia, China, Pakistan, India, Netherlands, and others on the call. So welcome to all of you as well. In terms of what you can expect from this session, we will go through context setting for the project, the Dragonfly overview, the specifics of AI and Dragonfly, the impact of Dragonfly at FUD. So that includes the trial outcomes and results. There'll be a 15-minute break in there, and then we'll come back and look at lessons learned and the path forward and what the implementation roadmap looks like. Going back to that vision for knowledge sharing, if we want to accelerate adoption and implementation, that's a really critical part of this conversation. And then there will be plenty of time for Q&A, so you will be able to ask all of the presenters any questions that you've got and have a great engaging conversation towards the end of the session. So with that in mind, I'll do a quick introduction of our speakers who will give you much more information as they go through the presentations. But welcome to our team from Jacobs. So we've got Mark, Adam and Ramesh. So Mark is water, wastewater and sustainable infrastructure professional at Jacobs. Adam is condition assessment, rehab services regional practice lead, and Ramesh is director of products. We've also got our team from First Utility District of Knox County. So welcome to Pat and Bruce. So we've got Director of CMOM and General Manager joining us. And then welcome to Ravi from Hitachi, who is VP and Chief Innovation Strategist, Big Data and Analytics Solutions. So finally, from me, just a huge thank you to all of our partners here who are coming in the spirit of knowledge sharing and sharing the lessons that they've learned. And thank you to all of you for joining the call who can take these lessons and hopefully accelerate your journeys within your businesses. So with that in mind, Mark, I will hand over to you to start getting us into the juicy content. Thanks, everyone.
Thank you so much. I appreciate that, and I appreciate this opportunity to participate in this session. So I'd like to start off with just giving some background, really, context on existing industry processes. So typically, when we're looking at gravity sewer inspections, they are generally done using closed circuit television and, basically cameras that sit on a little robot as such and are driven through the sewer itself. And that enables you to get an idea of what the condition of the sewer is. So you're actually physically looking inside the sewer. And then as you're going through doing the CCTV inspection itself, you'll be typically coding defects. So if you see a defect within the sewer, you'll identify that, and then you'll code that using industry standards. So then your trained technicians typically will then view all of that data, and then they'll assign, as I said, the particular defects, and then also the severity level of the defect as such. Then your engineers and your managers, they'll take that data from the technicians, and then based on that information, they'll determine what corrective and preventive maintenance is needed and what next steps need to be undertaken. And they'll take a look at those in conjunction with, the condition of the collection system and the available budget. So this is quite an intensive process. So there are some issues associated with this. You know, the throughput is somewhat slow, and it's limited. You know, you're having to physically inspect the pipes, stop, look at the defects whilst you're doing the inspections, code them. You know, then the codes have to be reviewed, as mentioned earlier, and that can be, you know, somewhat tedious. You know, it's not a quick thing to do, and it is very time consuming. You know, the human output itself, for example, you know, whilst you're using trained technicians, we are only human. And, you know, irrespective of if you've got two technicians that are maybe at the same level of experience, there is some subjectivity, and there can also be errors. You know, I mean, if you're looking at miles and miles and miles of CCTV recordings, you know, it is tedious, and it is easy to maybe potentially miss something if you're doing that day in, day out, 8-9 hours a day. So as I mentioned, it can be error prone, and it is subjective, and you can be inconsistent. Now, you see the graph on the bottom left hand side of this slide, and that kind of shows, this is for the US, just to give you an idea that, you know, the investment in water and wastewater and sewers, you know, in the US, it's like a $50 billion a year cost, which is, you know, it's a huge amount of money. But the interesting thing is that, you know, when you're looking at your wastewater system, you know, to determine the conditions, you've got to have these sewer inspections. And because of some of the items that were mentioned previously, you know, we're finding that within, at least in the US, that particular industry, you know, you're getting a backlog of somewhere in the region of $400 million a year, which is a huge amount of backlog. And, you know, if you don't have that information, then it's difficult to know, you know, the condition of your collection system, for example. So, you know, there's just the background of how things are at the moment. So now I'm going to hand over to Ramesh.
Yeah, thank you, Mark. Yeah, so this is an area that, you know, Jacobs as a engineering company, global engineering company, identified as an area where there's a lot of potential to provide some very valuable solutions to the industry. And our approach in this kind of a very high-tech space from the last several years, we appreciate the partnership that we have. It's a long-term strategic technology partnership with Hitachi that brings us into, you know, the newer technologies such as AI, machine learning, and that partnership is what we have jointly used while working with several utilities to create Dragonfly. And now we have the partnership with First Utility, who is our client as well, and we are working in a, you know, very, very collaborative way to deliver the Dragonfly solutions, and we learn, you know, from both directions. And, you know, all three of us continuously learn from each other. And that's the way we proceed to provide, you know, similar solutions to other customers as well. Now I think I can hand over to Bruce from First Utility.
All right, I think we've got it. Thanks for having us today. I'm going to talk just a few minutes about some general terms. First, let me give you a little bit of background on me. I actually, in a previous life, was a program manager for CH2M, which Jacobs purchased, and worked with a team and doing a lot of sewer rehabilitation and just a lot of utility assessment. So I've taken this job about 14 years ago. And one of the things I learned really quickly was when coming to this side was that if there's a problem, someone else many times has already either found a solution or is evaluating a solution. And so learned really quick that knowledge share is the key to a high-performing, successful organization. And so that's kind of been our mantra. Whenever we have an issue, many times we will go out to the industry and look to see who has done what, where, when, and what the results were. This knowledge shared, it helps us manage risk. It helps us more easily define our ROI on what our expectations will be. And and then candidly just helps make our jobs easier to get feedback from the industry and other utilities and engineering firms and vendors. An example of this, we talked about accelerating the adoption of new technology. This slide didn't forward. I apologize. I'm an old school IT illiterate sometimes, so bear with me.
You just need to press take control, Bruce.
Oh,
along the top there.
Yeah, I did. I'm sorry.
You're fine.
Okay, I've got it. Okay, I apologize. Again, I'm an IT illiterate. I'm an old school guy, but let me rather my thoughts here. But the acceleration of new technology, I've seen in my career many times new technology is good or bad. And when there's a good technology like Dragonfly and someone tests it, proves it, and quickly determines the ROI, can share this information, it kind of helps others along as they start to implement this. So that's my external. Internal, that was external. I'm sorry, one more. Okay, I'm talking about my internal, and I apologize. I'll get there in a second. Internal knowledge share. This is one of the most important things I believe is necessary for a high-performing organization. I believe that your decision makers not only consist of the management team and the engineering firm, but it also consists of the techs and the operations staff. And we always have all those folks, as well as our financial folks, at the table when we're making long-term decisions. And enables us just to make decisions much quicker. The folks in the field who are gathering the information sometimes understand things much better than we do. I also, candidly, we call it silos, or in my world, I call it sand piles. I don't believe in sand piles. I believe the more collaboration you have in your team, the better things will be. And it promotes a culture of problem solving. There are multiple instances where there has been an issue that our technical team has been dealing with, and our operations team, when brought to the table, have come up with decisions that have saved us millions of dollars. So one of the bullets here we've got is it reduces the impact when team members leave or retire. This knowledge share internally trains up our younger staff, and it promotes our succession planning. And one of our biggest successes has been that through taking young staff members and putting them with older staff members and transition and transfers this data as our workforce has gotten older and has retired. And as far as organizational efficiency, there is a direct correlation between our finances and the methodology behind how we do our work and how we share our information. A little bit about First Utility District of Knox County. We are in an extremely high growth area here in Knoxville, Tennessee. We met our 10-year growth plan in 2 years over the last couple of years. We serve about 105,000 person population and got a lot of high density multifamily housing. There's about 42,000 water meters and 38,000 wastewater customers in our area. So some specific facts about us. Our service area is 78 square miles. As you see, we have one water plant and one wastewater plant. Our wastewater plant has a biological capacity of 18 million and hydraulic capacity, I&I as we call it, of about 35 MGD. Treated about 3.3 billion gallons of water last year, and you can see the averages. We also, with the 478 miles of gravity sewer, we also have about 200 miles of low pressure sewer that serves a specific portion of our area. And when it comes to talking about knowledge transfer and innovation, we actually take a different, we have a different opinion on the use of low pressure sewer and the value that there is to it and the ROI on it as well. So we might get into that a little bit later. And we have a little over 14,000 manholes. And we all have an aggressive manhole rehabilitation program as well. Pilot study. Adam, do you want to talk about this some, or how do you want to?
Yeah, I can kind of cover the pilot study. So
Oh, Adam, sorry. I think Bruce has obviously muted himself, so we can't hear you. You just have to unmute yourself.
yeah, sorry about that. So First Utility District undertook a pilot study of about 84,000 linear feet of gravity sewer. And when we first started discussing the use of artificial intelligence to review this CCTV footage, some of the big components that we discussed was quality output. How did the AI compare to the manually coded or human coded data? Bruce and his team, Bruce and Pat, were very interested in the financial benefits. What was the cost? What was the return on investment? How does this impact our business operation? And also wanted to provide detailed insights into the asset condition. So when we do this, collect this CCTV footage, based on the AI coded data, how can we provide detailed insights into our asset condition? What's the remaining useful life of that assets? And, through this pilot study, we also learned that this allowed staff to focus on priority assets. And we'll go into that in this case study. But overall, after doing this pilot study, there was a higher value for the resources and cost and ROI.
So I'm going to talk a little bit about our historic process. It was a manual. It was very it was very effective, but it was also very tedious. We CCTV'd about 20% of our collection system annually. In the states, normally the goal is about 10%. So if you cover your system every 10 years, you've kind of met the expectation. But we were highly aggressive with our targets, and so if we made it through our system every 5 years, we had all that data to code and look at. So our process we would have TB trucks and our coders would sit in the trucks and manage the data being collected. And then our maintenance staff would help code that. Critical defects were resolved immediately. There would be a work order developed. Staff would go out, fix the problem. And then there was a manual assessment, and everything was put into our CMONT plan. So from there, we've got a 10-year long-term capital plan. It's about $340 million. And from there, we would develop between our capital plan and our asset management plan, what projects we were going to do and lay those out. So when this project started, we started discussing this project. One of the first things that, came to mind and was shown apparent almost immediately was a 75% reduction in cost. So with the workload we were using or going through, that cost savings was an instant hit. The process was really user friendly. The implementation, Pat's going to talk about a little bit more later, but it was pretty easy by industry standards. And it was easy to see the overall results of the health of our collection system. So, and the productivity was amazing, how much quicker we were able to evaluate data and free up our staff to do other things. And there was almost zero risk for this compared to the ROI that we were going to get in return. I think the first 84,000 feet cost us $21,000 to evaluate. So that was an extremely lucrative opportunity for us to save money.
Thank you, Bruce. I'm going to talk about some of the industry challenges that we're facing So you can understand from some of the things that you've already heard from FUD that there are a number of pain points. And, you know, the pain points in the US are somewhat similar to the UK. You know, the UK has some specific issues, but generally, you know, as one can understand, you know, all of the sewer networks, they're all aging, you know, they're deteriorating, you know, to a certain extent. They've sometimes been considered kind of like fit and forget, and they've been in the ground, you know, for decades in some instances. So, you know, there is deterioration in the systems. We have increased sewer flows. You know, there's climate change, for example, which is changing the way that, you know, the rainfall that we have, for example, in a combined system impacts the system, and storm sewers are impacted. And then also urbanization, you know, with population explosions and more properties being built, you know, potentially, you know, a sewer that was put in 50 years ago now maybe has to handle, you know, considerably more properties than it was originally designed for. And then there's financial and resource limitations. You know, not only is there a reduction in the workforce, you know, you have people that maybe knew the system inside out and back to front, and it was all there up in their head as such. And, you know, they've worked for a district for maybe 50 years and they've retired. And then you have the skill shortages that seems to be impacting almost every business sector these days. And then, you know, when you are able to get labour, it's more costly these days. So again, you know, that puts more stress on the finance. And then, as mentioned before, you know, a massive CCTV backlog. Okay, you have all that information, but you don't necessarily have the resources available to actually take that information and implement it within your management plan. And then obviously some of the more specific UK things, you have performance league tables and the financial condition of the particular utility. And then also there's the public perception, you know, perhaps their perception is more a case of, you know, they're looking at maybe CEO benefits and shareholders and thinking that the utility maybe isn't providing the performance when they see, you know, they hear stories about, you know, sewage being discharged into rivers and lakes, etc. So why are utilities turning to AI-based solutions? Well, you know, as we've heard multiple times, there's a lot of data to be processed, and more data is created on a daily basis that needs to be processed. We have a lack of internal resources and staffing to process that data. And then the visual recognition from a human point of view, you know, the coding can vary from person to person, although the people doing the coding are trained technicians. You know, as I mentioned before, we're all human, you know, there is some subjectivity for sure. So you can get inconsistencies and the quality can vary of the assessment. And then it's a tedious task coding sewer defects, and it's also time consuming. So the AI solutions, they allow time for the staff to free up so that they can then focus on other high priority and high value tasks. So to introduce Dragonfly, this gives you basically, you know, this gives you a description of what it is and what it does. You know, it's an AI-powered condition assessment and guidance tool that cost effectively manages collection system infrastructure. So it's an award-winning product. We were a finalist for the best AI product in the CogX Awards in 2023. And then this year for the Global Water Awards, the GWI, we have got the Distinction Award for Smart Water Project of the Year. And then Jacobs is also an approved supplier on the UK Government Crown Commercial Service G-Cloud 14 framework. And Dragonfly is part of that. So that's like, I believe, digital services. So Dragonfly is included within that. So to give you an overview on Dragonfly, it's basically, as I mentioned before, a digital solution for condition assessment. And, you know, that was created in conjunction with our technical partner, Hitachi. So what it enables you to do is rapidly produce accurate output to industry standards. So obviously for the UK, that's WRC standards, so MSCC 5. And then you can use that in your existing workflow and your computerized maintenance management system software and CCTV software, for example. And then it also has the added bonus of providing business intelligence. So Dragonfly has a built-in integrated asset management module, which is powered by Argon. So that's another one of Jacob's proprietary tools. So it supports asset management. It enables you to optimize reinspection and maintenance schedules, for example, and prioritize your asset management and rehabilitation planning. So it basically gives you an idea of, based on the data, what your next steps should be. So Jacobs here in the US has our own CCTV and inspection crews. So we effectively maintain a number of collection systems, and as part of that, you have to inspect them to be able to manage them. So we have decades of data for CCTV inspections. So we were able to analyze that and determine that approximately 30 to 40% of that time is spent by humans doing the defect coding. So what you see, the timeline here, this is like your overall timeline. So it's like start to finish from when you're doing a CCTV inspection to getting your output reports. So you can see you're initially going to start with, you may be going to, recon the site, and then you'll mobilize and set up, then potentially pre-inspection cleaning. Then you've got to drive the CCTV camera, so drive the robot through the sewer. As you're doing that, you have the human input there, actually looking at the defects, determining what the defects are and coding them. Then you finish up on site, so you demobilize. Potentially, there might be some maintenance to your CCTV robot. Then you have your data transfer and import. And then, the data that you've imported, that you effectively created whilst you're out on the site, that needs to be reviewed, back in the office. And from there, you can then create your overall CCTV report as such. So you can see that the two sections that include the human coding, they're easily 30 to 40% of the total time that is spent. So Dragonfly has a big impact on that because it can rapidly reduce that time spent. So to give you an idea of how simple it is, there really are basically 3 steps. It's very simple. You upload your data, so you have your CCTV video information and your pipe inventory. So Dragonfly is cloud-based, so there's no software to purchase, no installation costs, no yearly licenses, no seats or anything to view your data. And you're always going to get the latest version of Dragonfly. So you upload your CCTV video, and in conjunction with that, there'll be a pipe inventory that goes with the video. Then Dragonfly does the analysis. It will review that information, and then the data that comes out from Dragonfly, you then have a PDF report potentially and a Excel data export. And then also we used the integrated asset management module within Dragonfly to provide analysis for proactive asset management. So this gives you an idea of the kind of information that you'll get from the integrated asset management. You can see there that there's a couple of different dashboards. And the really good thing about it is that, the integrated asset management module, again, it uses AI to identify priority pipes, for example, plan re-inspection needs and maintenance needs, and give you some basic cost estimates. So it gives you that business intelligence that you need to manage your system. And you can see there's a couple of extracts from the data that typically you can expect to see. So it gives you an idea of what you need to do next for re-inspection, maintenance and rehabilitation. And then the lower image on the left, that gives you an idea of your rehab costs estimates and the schedule. So some of the value, to go over the value proposition that Dragonfly provides, you get high quality inspection, insights and decision making. It increases your productivity and efficiency, and then it provides O&M capital cost savings. And there's more details on the slides. I won't go through everything individually. I just want to go over the main header points. And then it improves your labor and talent management. And then likewise, we have a partnership, superior partnership you get from trained industry leaders. So Hitachi is an industry expert in AI, and Jacobs is an industry expert in water, wastewater, and collection systems. So now I'm going to move on to hand over to Adam so that he can give some insights on how Dragonfly works.
Thank you, Pat. So we've built Dragonfly to kind of work in a few easy steps. The first process is uploading the video, the raw CCTV footage. We also need the header information. We need a little bit of pipe information just so we can ensure that the video file format matches a unique asset ID. Once we upload that, the Dragonfly AI algorithms go to work to code all of the defects. You can see all of those results, we get the AI results. We do a quick QA/QC to verify quality, and then we push those Dragonfly coded defect results out to you. We also push those through the purple there is the Argonne AI powered insights. And I'll go into what that covers, but this takes your defect summary. We've all seen the defect sheets and the defect outputs, and you can see every defect in your asset or in your entire system. However, what do we do with that next? And Argonne really solves that problem by giving the interactive dashboards and starts making recommendations of what to focus on. So you can take a large data set and the reviewer can focus on those priority assets instead of having to focus on every asset in your system. So the Dragonfly process, if we could review what's going on in the background, this is automation of what the AI is doing. AI does not perform in a linear fashion. It doesn't watch videos like humans. But if we could automate that, this clip would show that. So up in the upper left, we have our original inspection video. And then we start applying these AI algorithms in the background. And the one we've got in the upper right is a defect heat map algorithm. And this is showing the confidence in the identification of a defect. You can see the more confident it is, the darker the colors become. In the lower left, we've got an anomaly threshold algorithm. You can see as we pass these defects, you'll see different heights and widths out of that anomaly threshold. Again, this is building the confidence of the identification of these defects. And then we've also got a defect labeling algorithm. And so we've got a host of these algorithms that are running in the background. Hitachi will go into some more on this, but just wanted to give you a peek inside of the AI, the identification tool, and the AI in the background. So Dragonfly results, once we get that output from Dragonfly, we push this through Argonne. Argonne will calculate a condition score, and it also has an AI trigger in it. However, instead of a defect trigger, this AI is looking at defect and defect combination. So it's a predictive model that's trying to understand the deterioration of the pipe so we can better assign risk in the next steps of what you should do with that asset. And the next steps could be reinspection. It could be a maintenance schedule. It could be a rehab plan. And then we provide costing in that as well. But Argonne is that next component, so we can take that large data set, focus it down on priority assets, and then you can spend your time and attention on those priority assets and what you need to do to better your system. The Argonne results and the Dragonfly results can be easily viewed in BI dashboards. These dashboards will allow you to interactively click through. So if I click on the light green wedge, the rest of the dashboard will filter down to that data set so that I can quickly filter through large data sets and see those assets that I'm interested in. We provide the structural grade in the blue colors and the blue shades, and we provide the maintenance grades in the orange colors there. So if you're interested in where do I have maintenance issues, where do I need to do additional cleaning or root control, you can filter through those maintenance grades and quickly filter out those assets that are important and that you need to focus on. And I think I'm going to turn it over to Ramesh to talk about the Dragonfly history and future here.
Yeah, thanks, Adam. So as we've learned about where Dragonfly is right now, let's just take a look at how we got started. The Jacobs wastewater experts way back in late 2018 kind of had some innovation meetings in San Francisco with Hitachi, and the initial ideas were born late in 2018. 2019, both parties, Jacobs and Hitachi, we created some incubation funds, and then in 2020 we fully began the AI machine learning development work, and then we've been building that our system since then. We went fully commercial in 2022, in middle of 2022. And we continue to keep working with Hitachi because from the AI standpoint, and Ravi will talk a lot more about it, there is still a long journey ahead. And we are very privileged to have our partnership with Hitachi so that we are always at the cutting edge of the technology aspects. And, and we provide that collaborative work between Jacobs, our water experts, and Hitachi to bring, the guided development work on the AI. And as we are doing this, we have been, doing many projects in North America and US and Canada. And right now where we are is we are seeking to bring our technology into the UK market, and potentially further into Europe and then Australia as well. So that's kind of where our system is, and our future is obviously going to be maybe the AI technologies pathways will be going in many different directions, and the set of the features and all the capabilities that Dragonfly will provide will continue to keep evolving, and we'll get into more of some of our future roadmap further down in this presentation. So with that, I will hand over to Ravi from Hitachi.
Thank you, Ramesh. Thank you. All right, we mentioned Hitachi a few times. I'd like to give you a little bit more insight into who we are. Hitachi has over 100+ years of track record of innovation and transformation, guided by our long-standing mission and values. We have structured our business across the globe to make the biggest impact on challenges facing the society today. Through collaboration with our partners and customers, and by bringing together the physical and the digital worlds, we deliver real impact and advanced sustainable living. We're about $57.5 billion in revenue, about 320,000+ employees. We started primarily in Japan many years ago, 100 years ago, and we are now in all cities or major cities in Japan. We then globalized, and we are in probably all the major cities globally. Our revenue is a mix of portfolio between IT, OT, and products that we sell. So in 2009, Hitachi pivoted and focused on what we call social innovation. The focus was really innovating and transforming some of the key infrastructures that advance the sustainable development of the society. So that we wanted to build technologies that were socially accepted and actually benefits the society in the long run. in the asset world, Hitachi has had a lot of experience building complete portfolios of business applications and asset-intensive industries, driving digitalization to meet business demands and operational needs. We have over $4 trillion of assets under management in 90 countries, 40 years of experience with over 1,000+ customers. So from a research point of view, we really wanted to relook at how we apply data and analytics a lot more holistically. We develop technologies and data with data at the center of it in many, many industries. And really what separates us from our competitors is our really deep understanding of the data. Because of our experience in a very large number of fields, we're able to abstract the data, ingest the data, analyze the data, and derive deep insights into how the information could be useful for our customers and solving really hard problems. Much more than any one individual player in the market. The advantage of looking at data from so many different industries, it gives us very good understanding of how to abstract the data and how really we can take advantage of the information to unlock the insights that we want to leverage. So it was not easy, right? We started a lot of the research originally, has always been done in, as a solution out or a product out or a technology out kind of a model. Basically, you invent it and then figure out how to apply it. Instead, we started with a co-innovation project where we were able to bring the market in approach, but really work with partners and customers co-innovating on what the industry would need in the longer run. So just no one company alone has a full world view of what's going on. Our partnerships here really matter. We then start building out, and it's not automatic. When you really think about collaborating across different organizations in a seamless one single team kind of a view, we really needed to re-embrace what co-innovation would actually allow us to do. So here we created a process for that. We started thinking, understanding what is the IP that we will develop, how do we share that vision with our customer, generate new concepts, validate them in a real setting. And then once the validation is done, we would then find a way to scale. Now, to scale it, it's not automatic. Again, we really have to bring in design methods. We have to bring in a good understanding of who the end user is, all through the journey of our concept proving, where we use ethnographic methods and service design methods to really integrate our technology into the process of scale and validation in the field. So our partnership with Jacobs has been very, very, very useful and complementary. It's a mix of two big worlds. One very deep domain expertise that Jacobs brings to bear for us, and at the same time, Hitachi has a very deep understanding of technology in terms of AI and big data. We were able to bring that to bear. And then the offerings that we have been presented in various conferences, and Ramesh mentioned how we've been winning the story in the market. Moving forward, I wanted to give you a little bit more insight into what was happening, with the technologies. Over a decade ago, the first form of image or computer vision into problems were mostly to deal with scale and translation variance. And the idea was how do I generalize my algorithms in a way that it fits much more broader class of settings in which the information is captured from, any specific controlled solutions and didn't actually pan out, didn't scale very well. An idea here was to be able to leverage those kind of settings where information could be captured from multiple infrastructure problems or any imaging solution and be able to apply the same kind of techniques. So that was the first task, is to be able to bring that leverage. So the kinds of problems that were being solved was to be able to identify, recognize objects within images to some extent. But that alone didn't solve it. Then the next step, the minute you got images, then and object detection, the next thing was to be able to track the same object across images or across a sequence of images. From there, the technology unfolded, evolved, and we were looking at segmentation, really separating one object from the other, being able to separate the object from the background, for example, or vice versa. And instead of just looking at bounding boxes, you can now have contours of objects, contours around the object, the shapes. So you can actually look at overlapping object. You can count the instances of occurrence of an object within an image or a set of images, etc. As these problems were getting solved, we started looking at technology evolve in terms of, how do we deal with data sufficiency problems, right? So some of the technology that evolved was really generative in nature, in the sense that can you have two players, one play against each other in terms of a generator generating an image out of thin air, and then the adversarial network, the discriminator then actually looks at validating whether that object belongs to the distribution from which it was trained on. So this kind of a model actually produced a lot of insights, and the byproduct of that outcome could then be used to train new models where we didn't have sufficient data. So the generative concept actually began there. Now, of course, the next thing was to be able to scale that, and we had efficient nets with bringing in architectures that will allow you to look at depth and width and also the resolution in different ways. Now the interest is really to be able to query images just the way you query a database. The question was, can you really query language, use language models to be able to query an image, get more insights from that perspective. So if you were able to query many things, text, sensor data in any other form, we should also be able to query images and be able to extract more and more information from it. And then now we are going into what we call multimodal technologies, where we are able to use and bind a lot of different models in the information into the single source and be able to extract information from that. Now, and you saw some videos in the earlier slide where Adam presented, where we were looking at what we call attention. So being able to look at, in that entire video sequence, where exactly is my model looking at and what kind of features is it detecting? And that's the brightened area that we look in within the image. Now, you can easily imagine that information extraction and retrieval and insight retrievals could actually have a number of other features augmenting. It's not just the cameras. You really want to be able to take sensor data. You want to be able to take operator notes or CCTV footage. All of them bring that back and then start systematically extracting more and more information from handling larger and larger scale of data and be able to take that to your advantage and build a very deep insights and a dictionary of knowledge from that data set. So video technology is continuously evolving, and we want to, as the technology evolves, we want to be able to take that and apply it to the use cases we have in this industry. We don't want the industry to be trailing. In fact, be able to take advantage of more advanced techniques, and we are continuously doing that within very tight timelines. So broadly, one way of thinking about how AI is being applied to the industry's use cases in this case is just, you have some CCTV data, and then the idea is to be able to apply some techniques, and you'll get some leverage out of that. But really, in the longer run, we want to think about how do I capture data so that it can be analyzed better. So right now, the data that's been captured was mostly with the intent to have a human in the loop, take specific decisions, be able to actually analyze and annotate the videos as they go along. If you start thinking about it fundamentally differently, turn it around and say, what do I need to capture so that I can have this technology, have technology leverage and automate the outcomes that we are looking for. So that will require us to have a lot more systematically designed systems that will bring in a combination of reconstruction, which is being able to capture data well, reorganization, being able to learn from one domain and apply it to another, as an example, and then ultimately recognition, that we are always that we have been talking about. The recognition is the most common one that you would hear in terms of computer vision problems, but the reconstruction and reorganizations is just so important. Are very important for us to get a very good outcome from the systems that we have. Now, it's very common to think about these being run in separate loops, as in do recognition separately and reconstruction separately and reorganization separately. And that's really how it is in the current form, right? If you think about it, you're capturing data and then you send it off to some other system that then looks at how do we recognize information from that video stream. Ideally, what you want to be able to do is to be able to bring all of these features into one system, one single loop, so that you can learn and you can improve the kind of capture you want and be able to reorganize the data so that if you don't have the right information or if you see something new, can I learn from a dictionary of learnings that I have from the past to be able to apply and reconstruct the information that's missing or partially observed. Now, it's very similar to how humans would actually go around. If you look at a human, we don't see all we want and then walk. And then if there's something in the way, we don't, separate these. It all happens in one single loop where you see in order to move and you move in order to see. And if there are obstacles, you move around those to figure out how to see the path that you're interested in. And likewise for reorganization, be able to learn from one domain. You may not have been trained on something new, but be able to do that very instantaneously or intuitively too. So we want to build systems like that, where you can bring all of these faculties of computer vision into systems of decision making here. So more recently with ChatGPT and other technologies that evolved, there is a tendency to have a human-like interface, the human prompt interface, where you want to be able to ask the questions in very simple English terms or language terms and be able to express your intent. And then the idea is that our model uses an agentic architecture where we deploy AI agents to learn from that intent, map it to a domain context. So you have a lot of domain knowledge, you map that intent to what kind of a domain interest we have. And then from there, the idea is to strip down the domain and focus on the instance level, where you focus on a very atomic technology problem and a process problem, and from there down to and relegate an agent to be able to solve the task that you have. An example of that would be, detect an object in this image, or detect a sequence of frames where this object is seen, or another example would be, tell me other segments within the pipe that have similar features. Those kinds of tasks can be allocated to a specific agent. And you can have a large number of agents doing specialized tasks. And once you strip that down, then you want to be able to present the information and results back in a way that's useful to the end user. So you want to be able to go back and add the functional decomposition that was done. You actually add the function as to what function did you solve for, and then add the knowledge back, and then be able to present the information in a way that a user can query the information, the insights they're looking for in a very interesting manner. So the idea is to have these built as layers and layers of neural networks that will talk to each other, consult each other, each of these other layers, and be able to extract the information we need. So here is an example of how this might pan out, in where you're looking at a video And then you can also have the Gen AI look at it, and you can start querying the information. You know, what exactly is happening here? Is a video being looked at? The attention models are looking at, you know, what's going on. Now, as a user of the system, you might say, you know, explain this particular scenario for me, or what do you see, and what are the properties that we can recognize from this image or this video? And the system is able to not just recognize an object, but also be able to provide a level of insights and information that might be useful for the user. And then the operator of the system were to take that and add particular notes, that information can again go back and be augmenting the algorithms for us to look at more deeper insights as we go along. So moving forward, you know, it's not just what we've been doing. We really have thought through this. We have built a systematic roadmap of where we want to get to. The first stage of using technology here was to bring digital technology to manual operations, right? That's what you know, allows you to be able to upload the data, build out a common interface, be able to build a digital fabric and around the systems that we were looking at. The next phase was to be able to take an manually operated system to automate it, to automation using an AI-assisted automation model. Moving forward, we really believe that these systems would become smarter. You would have a smart infrastructure solution instead of us serendipitously discovering the condition of the pipes or a condition of the sewage line. Can we actually have the infrastructure tell us where to look and what are the common areas that we should be looking at? And the sensing system can actually advise us exactly where to go look for the conditions we're looking at, we are interested in. And eventually, you can imagine that these systems are all going to be always on. The system is collecting data. You would have a metaverse where all of these data is actually plugged in to the metaverse. There are experts who can sit in, collaboratively be able to discuss what's going on with the condition, take specific decisions. You can have trigger workflows from there and be able to assign activities. You can do what ifs, you can do a lot of simulations. All of those things happen within the realm of a extensive metaverse system that could be always on, collecting data continuously. It gives us both a historical view and also a predictive view of what would happen. With that, I'd pass it on to Adams.
Thank you, Ravi.
Sorry, guys, just to interrupt very quickly. We're running a little bit over time, so if there's any chance you could get through your bits a little bit quicker than planned, that would be great.
Yep. Outstanding. Thank you. So the Dragonfly sample results, the results can be accessed via our website. These are downloadable files, as we've talked about. We've got standard PACP exchange for our US compadres and WRC for our UK users. You can get the PDF results, and there's a zip folder containing the defect images. So all of this is accessible online. A little bit of the sample results. This is the standard PACP report that we might see in the United States. And the report contains the pipe graph as well as the defect codes and attributes and photos that were identified using the AI technology. Inspection results can also be viewed in the web browser with sort and search features and photo views. This makes everything accessible, so you can see the Argonne results, you can see all of the results. So we look at the web browser and the user interface as a one-stop shop to understand and review all of your assets and to see those defect codes. Again, we took a look earlier at the integrated asset management module that's powered by Argonne. These tabular downloads of the assets, all of this information that's on the website can be downloaded and reviewed in any CMMS tool set or any GIS tool set It's your data. We want you to have your data and use that data to make smart decisions within your collection system. So all of this can be downloaded and pulled back into those existing tool sets that you've invested in. With that, I'm going to turn it over to Ramesh.
Right. Thank you, Adam. Yeah, just to kind of wrap up before we get more into the actual FUD specific information, Dragonfly overall business strategy is totally aligned to the overall Jacobs water market strategy. And the water strategy for Jacobs is we want to bring industry-leading innovation to produce unique kind of solutions that give the highest quality results for our clients. So that means that we invest in leading edge technologies. And that's kind of our long-term commitment here. We work with Hitachi for this. We want to make sure that our clients can always rely on the results that we provide. So while we continue to advance the AI technology, we also maintain this human in the loop operation so that ensures the clients can always rely on the final results. We believe in working and forming strategic and commercial partnerships. We join with various industry players, not the long strategic partnership with Hitachi, but other players as well, such as smaller software companies or other entities and hardware CCTV companies as well. And finally, we work as a trusted partner for the long-term journey for our clients. We're not looking at some point solutions to sell, software licenses only. We are here to guide our clients through the long-term journey. And so, we bring our expertise to our clients as a larger service provider with some of our digital assets as well. Okay, and I'll quickly try to wrap up here. Okay, so I think, can somebody move the slide here? It seemed to be stuck. Next one, please. One more. Yeah, thank you. So Jacobs, as Ravi presented as well, I mean, the applications of AI are in multiple fields. We believe from what we have learned over the last 3 years is that this technology is highly suitable in this particular CCTV defect inspection and asset management area. And we've seen the broad-based industry adoption over these years. And so, we've done work with a lot of customers, and our 3, kind of differentiated aspects is that we will bring you the high-performing AI that's going to be cost-effective and scalable. At the same time, we also provide additional, capabilities like our asset management and insights module. Plus, we also provide expert consulting and guidance where, our relationships with our customers for broader engineering work, we will bring that along with our digital solutions as well. So all of this, I think the goal for us is to make sure our customers are getting accurate information. They can also very flexibly collaborate and customize our solutions to their specific use cases and make it very easy to adopt and obtain some of the high ROIs that they are mandated to meet. I'm going to hand it over now to Bruce. Or is it Pat? Pat, take it away, please.
Pat, sorry, you're just muted. You just need to pop yourself off mute.
Can you hear me now? Okay.
Yeah.
So when Adam first presented the Dragonfly deal to Bruce and myself, I can honestly say I was a little skeptical, taking the human element and component out of, assessing sewer pipe, something I've done for 25 years. I'm old school, a lot of experience, not afraid of new technology, but when you start where I did in paper logs and VHS tapes, and now we're GIS mapping and, granted, CCTV software, we've come a long way. This was still a little bit scary for me, but I have to say a significant factor is Adam has done this for years too, and Bruce has been involved with as well, and basically they were a big factor in moving forward with this small pilot project. So basically, let me see if my slides. Okay. So if you get down to the coding and comparison, we basically, at first, we had to upload our own data. So I picked an area that I knew had some issues, but not really bad as far as compared to some of our systems. And the reason I did that, I didn't want to make it too easy. In my mind, simplified, that I don't want to make it too easy for Dragonfly to call out some defects and code things that, maybe are really obvious. So whether that's correct thinking or not, that's the way I looked at it. So, so basically we uploaded videos to the Dragonfly site, which we'll look at that in just a second. But so basically, when you look at this data, want to note we had 2 new operators in our vans. We have 2 TV trucks that run daily, a lateral truck, launch truck, and just a regular mainline camera. But as you can see, the red arrows point out the total defects found. So we do kind of push our operators to not stop and code every little thing, because if you've been in a CCTV truck in a sewer system, you could probably spend all day in 1 or 2 segments. But so a lot of things that Dragonfly picked up, we didn't code, but it just tells you how powerful the Dragonfly, what it does to code everything that it sees in the CCTV inspection. So, but and when you have 600 miles, we push production, so we don't want to stop and do every little thing, and that's worked for us over the years. We've been successful, but now we're going our 2nd, 3rd time through, so we need to be a little bit more thorough. But as you can see, that Dragonfly was much more thorough on different, and I know it may be hard to see, but root intrusion, some of the things we missed, Dragonfly picked up. Deposits were a big thing. Some of those were less than 5%, which the next slide, I think, tells you that, or one of the next slides. But so basically, some of the things we didn't code, Dragonfly picked up. So that was a plus in my mind. So, but the next slide, comparison, one particular thing that we coded, whole soil visible, which again, new operators are probably not the right code, but it does get our attention, get my foreman and myself's attention when they code it whole soil visible. And of course, if you can see, it's a tap factory intruding. Of course, Dragonfly, collapsed pipe with 100% blockage, and also intruding tap. So neither one really are, I guess, wrong, and they both are basically need attention quickly. So that Dragonfly did do a good job in picking up things that our operators miss. So, and here's some smaller things we were talking about captured by Dragonfly. Deposits settled. Again, some of those things we would not, we would not stop and code just because of the length of time. But so basically, that's kind of, Dragonfly picked all those up, and basically, if you looked at the map before, the number of deposits that was coded, picked up by Dragonfly was significantly more than us. Part of that was because of, like I said, our operators, but the other part was basically, something we wouldn't stop and look at. So let's get to the next slide. Okay. So here's some others that was captured by Dragonfly. And you can see in the notes there some of the small things that our operators did not catch, but Dragonfly did code and catch. And you can see the caption, AI captured the defect since it doesn't fatigue. And if you've been experienced with a CCTV, if you've ever done any of that, our operators can get tunnel vision. Basically, you know, they have bad days just like us, so they miss things. That's where the human error comes into play. That we feel like Dragonfly, you know, obviously it's been talked about that you know, based on our results, what we did comparing this section, you know, our results based on what Dragonfly captured, we were very pleased with that. And like I say, the amount of time it took for it to evaluate the 84,000 feet, it would have taken us much longer. Can't even put a time frame on it, but basically the time was a big thing for us, and also the cost savings, which we mentioned earlier. So real quick, that's kind of, we were very pleased with the results that Dragonfly got for us in this pilot project. And so we hopefully, we'll talk about it a little bit after the break, but plan to move forward with some more evaluation. So, and I think, let's see, I think that's it.
Thank you, Pat. And thanks to the team so far for a really great presentation. As I mentioned, we are running a little bit over time, so I am going to shorten the breakdown just to make sure we can fit in all the great material and some questions too. So I think we'll do a 5-minute break instead of a 15-minute one. Feel free to keep popping your questions in the chat throughout the break and throughout the Q&A too. And yes, so the time is 16 minutes past 3. We'll be returning at 21 minutes past. Thanks, everyone. Okay, so time's 21 minutes past, so we are going to pick back up with the presentation now to make sure, as I say, we can fit everything in. So I believe I'm handing back to Pat now to talk us through some challenges and what went well for FUD's perspective.
All right, thank you. So some of the challenges, I'll just real quick, I'll tell you, we have two, we have two TV trucks that run daily. One is a mainline truck only with a pan and tilt camera that basically just records everything in the main and can zoom up into the surfaces. And then the other truck is a lateral launch truck, which we can launch. You know, we have two cameras, one small camera that piggybacks off the main and can launch, you know, across under the road or up to 100, sometimes under 125 feet. So that's our two main systems. So the challenges, of course, in the new technology, new tool, we're still, you know, even I'm still learning a lot about the software as we're moving forward today. But so making our staff aware of the process and basically how we're doing things, just making sure we're trying to code things properly, especially with the new operators. And that was one of the challenges again with the new people starting, based on we had promoted some others, which was a good thing, but still. So during that time, we used GraniteNet basically, and I'm kind of Adam can share some of this also, that basically as we TV, you come to a lateral, you can see the red box there, that if you see the _1, _2, _3, those are actually lateral videos. So the way the software, we do it, we actually start a lateral inspection and it creates another video. So that was one of the challenges that we ran across, basically the way Dragonfly processes things. And I think Adam may be able to share a little bit more on how that was an issue at first.
Yeah, so we had some issues simply because of the formatting that came out of GraniteNet. We work with all CCTV software vendors, but the lateral launch presented some unique challenges because as they would launch a lateral and restart the inspection, GraniteNet would pause or stop the inspection. So we ended up with multiple inspections plus the lateral inspection. So we overcame those challenges. We worked with First Utility. We worked with our development team to make sure that we could handle those inspections appropriately and get a complete video segment that could be processed by Dragonfly. We also decided to record the defects in the laterals using the PACP output, which is a pipeline assessment output instead of the lateral assessment output. That's on our future path list to develop that out for Dragonfly, but currently we're just using the PACP codes, which are not vastly different from the LACP codes. There's a few, 2 or 3 differences, but for the most part, you can see the condition of your laterals as well.
So again, one of the original, we had to upload the data. We have since done things a little different, but some of the challenges we had originally, basically when we'd upload the data, basically I would pick those videos and also export a database to the Dragonfly site. And there were some issues, I think, with basically the sessions would time out. So which was a small issue. Jacobs, you know, it was kind of frustrating at first because you're trying to figure out, you're uploading a ton of video, and I would do it as I would leave in the afternoon, so it'd be doing it at night. And but Jacobs come up with a solution to that fairly quickly, and I can't tell you the ins and outs of that, but it was very, very quickly resolved, and there was no issues there. So basically, you know, when we did that upload, now we actually transfer data. Basically, they come into our CCTV server and grab our data, because we're doing another small project with them now currently. We sync data every Thursday night from both trucks, and basically Jacobs and the Dragonfly comes in and takes whatever new videos are current in that week, and basically grabs that data and then processes and evaluates them. And so that's kind of how we're doing things currently. So let's see, Adam, having trouble getting to the next slide. Can you do that? Well. So, sorry, go to the next one, please. Yeah. So what went well? The data automatically transfers weekly. I just covered that, and no human interaction needed. So, and that increases efficiency also. So, basically the PACP through the Argonne is basically has helped me tremendously. I mean, I'm still manage the CCTV data here at First Utility, but I've also got a lot of other things. We've got a total of 15 people and crews, digger crews, repair, the rehab, basically is all under me. So there's a lot of things that the Dragonfly Argonne has helped tremendously. I can, you know, basically get into the Argonne data and look, and like Adam showed earlier, which I won't talk about. I mean, he showed you pick on a certain thing if you want to see the deposits or cracked pipes or what segment. So it's really been a great thing that we've a great partnership, and we've accomplished a lot of goals. The time that we're saving is tremendous. So that's helped me overall in my day-to-day activities by being able to utilize that. And basically, because you can go through there and, okay, do I need to flush this pipe next week, or can it be a year? And Argonne kind of gives you all that information and lays it out there. So the path forward, again, talk about the automated upload. We are doing that now. And of course, security was an issue. We have a dedicated CCTV server, and our IT department worked with Jacobs. And basically, you know, we just don't let anybody get onto our CCTV server and grab data. And that was an IT thing way over my head. But again, they worked all that out between Jacobs and our IT department. And so they grab those videos weekly. So you can see we're going to keep processing videos. So again, like I say, we can save time and I can concentrate on other things. One thing we do need to implement our LACP program, which we've been good on our main line, the PACP, but that's something that in the future we'll have to look into that a little deeper. We've been concentrating on our mains, and we do TV our laterals, but We just don't have that assessment certification program. We're not utilizing that 100%. So, and get our field crews more involved in the tool set and data. So that's something with our new operators. We want to make sure they knew basically the CCTV part of it, and now we'll get them more involved with Dragonfly and evaluate and let them be able to get on there and look at some of the results. So return of investment, I think Bruce covered a little bit of that earlier, but 75% reduction. Basically, it's been tremendous, the savings that compared to if we had to hire a CCTV, you know, we do our own CCTV, but even to have somebody assess that for a consultant. So basically, it's increased our production in the field. One thing we're looking at is maybe going to a camera that's a 360, basically where you just drive down the pipe. If we're going to keep utilizing the AI and Dragonfly, then, you know, we could even, you know, we're production driven, like I said earlier, we can even do more CCTV and let, you know, obviously Dragonfly analyze more of that. So that's something we'll probably put in the budget in the next year or two. If you're familiar with the TV cameras, that's something that would help increase production as a, so cloud-based service. I don't know, Adam, maybe you want to talk about that a little bit.
Yeah, so I think the great thing about Dragonfly is that it is a cloud-based service. You know, we went above and beyond with First Utility to make sure we had a cloud-to-cloud exchange, so there was no upload, but there's a low barrier of entry to get started because it is cloud-based. We do have security in mind when it comes to our clients' data, and we ensure that we've got those security measures in place to protect your data. But really, once you sign up to utilize Dragonfly, as Mark said, there's no licensing fees, no seat fees, or extra needs. We're priced pay as you go, and so you can sign up. We'll get you on a call with one of our team members to walk you through the process. We did that with First Utility to ensure that they've got a seamless integration. We'll work through any issues you have with your organization. And really, we look at this as a partnership with our customers. And there are no pipe size limitations. So small diameters, large diameter assets, materials, there's no material limitations. We're using, as Ravi said, we're using visual AI software to identify those defects, and so we don't really have any limitations. So it's a low barrier of entry to get engaged. Bruce, I think, coined it best when he said it's low risk, right? Because there's no upfront investment. A few.
Sorry, we're few of the other lessons learned. We feel like it's important to partner with your client on data formatting. Everyone has different data formats, and we're looking for a couple of key pieces of information to rapidly process this data. One is the video file. The video file format doesn't really matter. We process all the industry standard video file formats, but we do need that unique asset ID and a couple of asset bits and pieces of information, and we can take that through the PACP header information, or we have a metadata template to make sure we've got everything and we know which video goes with what asset. Again, partnership, knowledge share, those are the themes throughout this, and the key to a good implementation is to share that knowledge, be open with each other, and partner with the client, and making sure that standard format that we get the data in the correct format to upload. It's not a hard process. It's just understanding what format our clients have that data in. And then working with the clients to understand their processes. You know, Pat kind of explained their process. And so we want to make sure that we cause as few disruptions to the business practices of that utility or organization. And we want to come along and enhance those business practices, not deter those. So some further improvements for efficiencies that we did for First Utility was that cloud-to-cloud transfer of data. That took another piece off of Pat's plate so that the information every Thursday pushes itself up to the Dragonfly cloud, and then usually within a couple of days they have their data and information back. It's been coded by the AI, it's been QC'd, and it's been run through the Argonne results, so Pat can log in and see those results. And I'm going to turn it over to Ramesh to talk about some future enhancements of the Dragonfly and Argonne toolset.
Yeah. Hey, thank you, Adam. I know we are running over, so yeah, our overall plan is to keep optimizing, you know, our AI platform. But in addition to that, we also have a few other things on our platform, on our roadmap. These are to take it into the regional specific customization, such as in the UK, learn about those markets, and work with collaboration in a different regions. We also have plans with the integration with other third-party systems, as well as with the broader Jacobs digital platform, which includes many other systems in the water and wastewater space. You know, and our engineering expertise that I've mentioned before, those things will also start to get slowly more embedded into the Dragonfly system itself. Yeah, and then there's a lot more, so I would not want to take up too much time here, but can somebody pan forward to the next slide? I'm having some technical challenges here. Yeah, so just to wrap up, we are really grateful to Spring and to all of you attending here for this opportunity for us to bring Dragonfly to the UK. We're pretty successful in the US, and I'm really thankful to FUD for taking the time to present all their findings. And very thankful to Hitachi for providing such a good background into the technology and our some of the things that I don't fully understand. Yeah, and we are excited to learn from, and we welcome the Q&A session. And I will hand it over back to Leah. Oh, before I forget, yes. So here are our contact information, which I think you can also provide any direct contact to myself or Adam or Mark, and please feel free to reach out to us. Thank you.
Thank you, Ramesh, and thank you to all the speakers so far today. It's been a really great presentation. If everybody could please, all the presenters, pop your cameras and mics on for the Q&A session. We've had a few questions in, so we'll start that off now. Perfect. Okay. I'm just going to stop sharing the presentation so that you can see our lovely presenters a bit better. Perfect. Okay, so first question is from Joe, who would like to know, is Argonne part of the Dragonfly package, or was that developed by FUD?
Yeah, I'll take that one. So Argonne is a part of the Dragonfly package. Those are two tool sets that come together as a complete package, the Argonne Insights. We had a partnership with Hitachi to develop the Dragonfly, but Argonne was a long-standing tool set that Jacobs was utilizing, and we included it as a part of the Dragonfly package because it is a differentiator. It does tell you what to do next with your assets.
Perfect. Thank you, Adam. something that so we had Dave pop some really good points into the chat about his own innovation, and he seems quite keen to collaborate with Jacobs and those involved with this Dragonfly project, and including those at FUD too. Do you have a sort of collaboration pathway at all that you could recommend to Dave to kind of get involved in this?
Yeah, we can, if Dave wants to reach out, we can connect. I can connect him with Bruce and Pat to get their insights, and we can discuss pathways for future work.
And as I said earlier, I mean, the process is pretty simple, and the risk is so minimal. In 34 years, it's probably as little risk as I've ever taken in trying to use a new technology. So, and I'm gonna be sure that he'll be pleasantly surprised by the return on his investment for what he has to invest in the process.
Perfect. So it is very end user friendly then, Bruce, from your perspective. It's a super simple.
Yeah, no brainer almost. Yeah, we actually, I signed another task order this morning to implement, to continue the process.
Amazing. Perfect. Thank you. And then Joe also just wanted to ask, how did you manage any tech issues, as well as the time difference between the two different companies? Did you have any sort of special things in place for that?
Yeah, so we have a long history, and Bruce touched on it. We have a long-standing partnership with First Utility. Jacobs has been doing a lot of work at their water and wastewater treatment plants, as well as in parts of their distribution. However, Pat and his team has always managed the collection system. Jacobs hasn't really done a whole lot there. But we have a trusted relationship. And so when we had tech issues, we would get our technical IT folks on the call, on the phone with First Utilities technical folks, and just make sure those issues were worked out. Because of that partnership, and we can be honest and open with each other about what challenges we're having. We were very open with Pat about, hey, your video format's a little different than what we're used to seeing. It's going to take a little bit longer to figure out how to stitch together multiple videos because it was pausing. So we were just open and honest and worked with them, and they worked with us as far as the IT and the technical challenges. And I think that's the best way to serve a client is just work together and tell them the challenges and then work through those challenges together as a team.
And the growing pains were minimal if you look at the big picture and the outcomes. So, I mean, there were growing pains, and but once those pains were solved, it's been a pretty seamless process from that point forward. So highly efficient, seamless process too.
Once we overcame those hurdles and we had everything implemented, the pilot study was about 80,000 feet. We've processed over 180,000 linear feet and continuing. So, it slowed us down a little bit on the front end, but the time savings on the back end once the project was implemented has been tremendous.
From a financial perspective, our plan is to allocate enough dollars over the next 5 years to process our whole system.
Wow. Amazing. Okay. Thank you. And then the next question is from Ryan, who wants to know, is identifying coding dependent on the CCTV operator stopping at defects and panning to view the defects?
That's a great question. So we use the NASCO standard. You all use the WRC standard. I recommend following that standard. However, you don't have to manually type in the code, and the standard kind of states you get the best results if you pan and tilt. So, and Ravi, you might want to jump in, but I always recommend that if you can't see it with the human eye, you're not giving the AI technology the best opportunity to visually see that. So if you drive the camera really fast, you have a foggy lens, it may pick up more than the human eye can. However, it's not giving it the best opportunity. So if you follow the WRC standard when doing your CCTV investigation, you're going to have a better outcome with and a better result with the product.
Amazing, perfect. Okay, so the camera is a really key part in this then, by the sounds of it. Perfect. Okay, so next question from Rachel, who has asked, have you been able to see much of a societal impact on the areas in which this tool has been utilised?
We were already considered, at least by a regulatory authority in our state, kind of the torchbearer for our state and the way we do sewer rehabilitation. So our system was strong and with very little impact to our community. Our long-term plan was already very effective. So we added this as just another layer to continue to improve ourselves. So by our regulatory standards, we were already kind of the shining star in our community. So it would probably be hard to define any more positive impact right now.
Absolutely. Thank you, Bruce. Mark, Adam, from a Jacobs perspective, I know you've done this in a few different water companies across the US. Have they kind of seen any big impact through those different use cases at all?
Yeah, I think the big impact. So County of Maui was one of our clients, and I think that's one of the shining stars. So Maui, if you recall, several years ago had some devastating fires across the region. And as a part of their recovery effort, we worked with the EPA to put out a contract to leverage Dragonfly to, they were putting out a CCTV contract. And so we were able to leverage Dragonfly in that contract. So the contractor uploaded video and we were able to analyze that video. And the primary reason they were going through this was to, they had a lot of inflow and infiltration. However, there were no homes remaining in those areas. And so they couldn't open their pump stations and their wastewater treatment plant as rapidly until they took care of that I&I problems to allow people back in to rebuild. So we needed a rapid way to identify those defects and then get those defects repaired. And so we had a CCTV contractor who processed over 100,000 linear feet through Dragonfly. They had two camera vans TVing all week. At the end of the week, they would upload the video. The week behind the video, we had both of those camera vans processed. And so they saw an increased production because they didn't have to stop and code the defects. They were giving us raw footage. They anecdotally told us they were getting about 2,500 linear feet per van per day. But they saw an increase in production of about 3,500 linear feet per van per day because they didn't have to stop and code the defects. And so 1 week after the contractor demobilized, we had a complete output and a complete look at all of the results and where the I&I was going. And so the County of Maui then contracted with Jacobs to rapidly do a package to get out on the street to get a contractor to make those repairs so they could get those areas opened back up. And so I think that's an extreme case of the impact of how you can leverage this. I hope no one ever has to leverage the tool set in that way. But the day-to-day impact for a lot of our clients is being able to rapidly see what's going on in their system and make decisions that much quicker to get repairs made and get maintenance issues taken care of to prevent SSOs. So I think that's kind of the middle case scenario.
And one other thing we had, there is an indirect impact that all of our customers, it's to their rate structure, because the more money we save, the less the impact and the burden is on the customers to pay for this. So there will be a direct, an indirect impact that they probably won't see, but they would have felt over years to come.
Amazing. Thank you both. Okay, perfect. So Next question from Ian is, have you considered using the AI to undertake more activities than just coding the current standards, e.g. estimation of infiltration flow from area of flow/seepage?
We have not at this time. We have a standalone flow monitoring program. So we have 100 wastewater flow meters in our system, and that information is gathered by a technician and feeds directly into our asset management plan. So at the current time, we have not, but I could easily see how that could be incorporated at a later time after we become more skilled at using the product.
Perfect. Thank you, Bruce. I've already asked that one, sorry, bear with me. And then final question from Ian is, any thoughts on pairing the CCTV visual data with other sensors, for example, temperature, noise, sonar, LiDAR, processed through AI tool to get insights not currently available?
Yeah, so we have a partnership with Hitachi to develop the Dragonfly tool set, but Jacobs is rapidly moving into the AI industry, and I'm sure Ravi has case stories of tool sets that they've developed, but one of our tool sets is Aqua DNA, and it takes multi-sensor tools, processes that data, and kind of provides an output. So, from our standard, from what we see in the industry, we see more clients wanting to move that direction, and it's being developed. But Ravi, I'll let you talk more specifically about Hitachi and what y'all might have developed as well.
Sure, thank you. I think in general, if I were to look at the slides I presented, we really dabble in so many different areas in so many different industries, and each industry has a very specific type of data that is relevant. And what we're able to do is, independent of what the use case is, abstract the data in a certain way that can then be used to drive data-driven decisions, right? So we have done a lot of work in LiDAR and sensing and being able to put them all together and bind them together in the way that you can now query with one data set and then get response in using other data sets and things like that. We should be able to move between these data formats and sets so that we can actually augment the outcomes that with the right level of information and insights that's relevant for the decision making. And the challenge is really trying to put them all in a way that can perform at the speed of the business that you want to take decisions with. That's the idea.
Perfect. Thank you, Ravi. I think a couple more questions we've got time for. So Dave wanted to ask, I think Bruce and Pat, to what extent do Fort Knox rely on live asset data flow monitoring, and how is this integrated within the software to date?
Rely on the flow monitoring extensively into our long-term plan. But as far as I said before, it's being integrated into this, it has not been yet. We have a technician that's all they do is manage the 100 flow meters, pull it into our wastewater model, which, I've seen a lot of wastewater models in my years in the business, but people don't normally trust them. This is the first place I've watched my operators and my operations staff actually embrace the model because they trust the data that is fed into it on the water and the wastewater sides now. And it's been a really cool process to watch the engineering team and the operations team kind of work together to develop that. So it's critical to our 10-year plan. And the data itself has saved us millions of dollars over the last few years.
Amazing, thank you. And just to touch on something you picked up there, do Jacobs kind of provide a specialist training to use this tool at all as part of the package with Dragonfly?
Yeah, when we initially set up a contract to start processing data, we will jump on a Teams call, or if we're close, we'll come in person and make sure the client understands the data formatting and how to upload that. And we'll do a couple of calls and walk the client through that process a few times until they feel comfortable doing it on their own. We've got a lot of different ways we've implemented that. Bruce and Pat and the team here at First Utility are very independent, very knowledgeable. So they said, no, we'll take it and run with it and use the information. And so we said, great. And we walked them through it the first few times, but they're very independent. They're forward thinking in the way they operate their utility. So, and then we've got other clients who say, no, we want Jacobs to do it all. So we'll charge the processing fee for the Dragonfly, but we'll include consulting time so that we can manage that data internally. So there's a couple of different ways and different models we can utilize to implement whatever suits the client and their needs the best.
Perfect. Amazing. Thank you, Adam. And then just a private question we've had in for FUD. So what concerns did FUD have moving forward with utilising AI technology for sewer pipe inspection?
Primarily, it was new. You know, you've got a change in the way we're, as a society, we're thinking and using that new tool and trusting it. As I said before, when I came here, Pat's program was and I'd done this all over the United States, but Pat's program was as good as I had ever seen as far as sewer rehabilitation and the outcomes. And so when something's really good and then you start, you know, monkeying with it and changing the way you're doing business, it's a little disconcerting at first. That's why we waded in slowly, which I believe you should wade in slowly with all technology. So I think that was the major change, but now it's very easy to see after a little over, I guess, a year and a half of experimenting with this, that the outcomes the opportunities are incredible and the risk is almost non-existent.
Yeah, and you know, that was the whole reason for the pilot study. They had those concerns about data and data quality and how is this going to look being implemented into our day-to-day business practices. And, you know, if folks have those concerns, I would recommend a pilot is a great way to kind of take a look at it, low cost way to take a look at it, and kind of reassure yourself that you're getting that data and data quality you expect.
I believe we initially, we invested $25,000 in this process. And so that is almost nothing. You know, we're a $300 million a year business, and that's nothing basically in this big scheme of things to determine some long-term efficiencies.
Amazing. Okay, perfect. Thank you both. And then I think we've got time for one final question for the Jacobs team. We have been processing our CCTV sewer pipe inspections in the traditional way. How can we actually get started with Dragonfly?
If you will send Mark Wisby, Ramesh, or myself an email, we will reach out and talk to you about how to get signed up, uploading your data and leveraging Dragonfly.
Perfect. Thank you, Adam. On that note, I'll actually just pop that final slide that you had into the chat with all your contact details on it so that anybody who wants to do that can do so. Amazing. So thank you everybody so much. I think that brings us to the end of today's session. I just want to say thank you again to the presenters for all the hard work you've put into this PowerPoint and presentation. I think it's been a really great session with lots of really great information shared. So thank you for that. And thank you to FUD for being so willing and open to share your learnings and all that kind of stuff. That was great. Thank you to the audience for taking the time out of your day to come today. My colleague has just popped a link to a poll in the chat, which just helps us determine how engaging you find these sessions and how likely you are to take the knowledge back to your own organisation. I think she can pop the link in again because a few more messages have come in since then. But if everybody could take a moment just to follow that link and answer that poll for us, that's always really helpful in us helping these sessions. Any more questions you have, feel free to reach out to myself or the team. As I say, I've just popped their contact details into the chat. Today's session has been recorded, so anybody who wants to watch it back or share it with a colleague who couldn't make it today, it will be posted on our platform alongside a written case study and sort of any unanswered questions from today. And should the team be willing, I'll also share the slides from today's session too as part of that case study. So everybody, if you head to the platform, that is where we'll upload that, and that should be available roughly within a week from today. So that brings us to the end. Thanks again, everyone, for coming. Have a lovely rest of your day, and bye.
Thanks.
Thank you.
Thank you.